So welcome back everyone. So in the previous class, we talked about the regression analysis in multiple and single. So with one variables and two variables and two and more, and talked about some diagnostics, and then we did an activity in R to understand how to calculate some descriptives and then do the diagnostics for a single regression, simple regression, and multiple regression. Today we are now introducing a new type of a variable. We call it qualitative or dummy variables. So this session will help you to understand how to make a dummy variable and how to understand what they are doing in the regression model. So first start with the definition or what are dummy variables. So dummy variables are actually designed to measure some quality. So it's a categorical explanatory variable which has two or more levels. Means if one quality has two or more types like gender, male, female, or then we can code the data in a way that each code represent one characteristic of that quality. Okay, so and that coded data is used in the regression model to control for the qualities that are available in the data, since the data could change because of that quality. Remember the example that we did earlier is about the sale price of a car, which is second hand. So if the car is local, it might have a lower sale price as compared to car which is imported, or a sale price of a car which is durable might have a higher sale price as compared to car which is non-durable brand. So it means the qualities do play a role in determining the nature of the relationship. So that's why we study these demi variables to what you call it, to make sure that our estimates are not ignoring the fact that the qualities are there and the data is changing because of that quality. So so regression will provide us different levels of a data. So if you have a dummy variable in a regression, what will happen? It will divide the regression into two or more types. It depends upon how many levels are there in the dummy variable. So if the dummy variable has two levels, mean male and female, so it means it will make two regression lines. If the dummy variable has three levels, means it is a senior, junior, and tenured, then it means it will have three regression lines. So the number of dummy variable needed is a number of levels minus one. So it means uh, and then it says that dummy variable will change the intercept value. Because of that there will be new lines, but it will also, here we also assume that dummy variable is not changing the slope for other variables, that's why they are equal. And then how many dummy variable we add? We could add dummy variables minus one. So if your dummy variable has five levels, so you will put one level as a benchmark and can use other four as a dummy variable, so that you have, because the qualities cannot be measured directly, we measure in terms of comparison with each other. So if we make one of them as a benchmark, then we can compare other qualities from that benchmark, so that we can see how different they are. Otherwise, if we do not keep anyone as a benchmark, we would not know how they are actually changing. So there will be no scale, no comparability. So this is initial concept. So let me move forward. So, so dummy variable model. So let's suppose we have a regression line where y is the sale of a pie and x1 is the price of that item, and x2 is the day, if it is a holiday or not. So it's a quality of a day, if that day is a weekday or a holiday. Okay, so or it's a, if it's a weekly data, so he's saying that if that week is a public holiday or not. So the x2 is a qualitative variable which is coded into numbers, and the numbers are mentioned here. Here 1 means if that week has a holiday, and 0 means if that week does not have a holiday. So he is proposing that his sales are changing first of all because of price. Secondly, it is changing because of the fact that the particular week uh, uh, has a holiday in it. So if there is a holiday, he expects that there are more customers and there will be more, what do you call it, more sales. So this is a particular regression line and how we write the dummy variables with the regression line. So let's go down. Let's go down and write the equation. So when we estimate the model, so let's suppose that we have a particular value of x1, and rather than disclosing it, keep it aside because it's a continuous variable. We divide the regression in terms of the types of values that x2 could have. So remember, it could have 0 or 1. So first of all, we'll write for 0 and another for 1 and solve the equation. So when it is 0, so b2 multiplied by 0 is 0. So there is nothing left. So regression line is y is equal to b0 plus b1 x1. And when b1 is 1, so 1 is disappeared because it becomes a constant. So b2 and b0 will be added because both are now constants. So the regression line is y is equal to b0 plus b2 plus b1 into x. It means that the dummy variable has divided the regression line into two lines, one with holiday, one without holiday. It means this dummy is actually helping us to analyze what we discussed earlier, that it is a with and with and without relationship. Okay, so with holiday and without. So you can notice that when there is no holiday, the intercept is smaller because this has been disappeared. So it is disappeared because it is multiplied by 0. So it means that the base sales with no holiday is b0, and base sales with holiday is b0 plus b2. So the slopes are same and the slopes are defined by b1, and the starting point is different. So it means the dummy variable could do, first thing is that it can separate the regression line into two types which are depending upon one quality. Okay, so this way we can actually measure the effect of a quality, that if there is a holiday, the sales will increase by b2. So interpretation is that the interpretation of this variable, let's go back and do the interpretation in the previous line. So let's go back, and so interpretation of this x2 is, if x2 is equal to 1, then sales will increase by b2. It can be decreased if b2 is negative. And why we are not interpreting 0? Because let me complete this interpretation. So if x2 is 1, then sale is increased by b2 as compared to x2 is equal to 0. So the interpretation is actually comparative. So we do not need to interpret the case x2 is equal to 0, because we already know that when x2 is 1, it is higher. So it means when x2 is 0, it is lower. So this way we interpret our dummy variable. We interpret it in terms of its value is equal to 1 if it has one level. So let's move forward and see what will happen for next concepts. So it has talked about that we can also check for the significance of that holiday effect if that B2 is significant. So we'll check for the significance of B2. So he has estimated the model. So sales is equal to minus 300 plus 30 price, minus 300 minus equal to 300 minus 30 price plus 15 holiday. So sales is the number of pies sold per week. and price is in terms of dollars. Holiday is 1 for holiday week and 0 for no holiday week. So B2 is 15. So its interpretation is on average, sales were 15 pies greater in the weeks with holiday than the weeks without a holiday, given the same price. So it is included the similar things that we did earlier. So how we interpret this is the sales are 15 pies greater. Why I write pies? Because the units are pies greater in a week. So it because it's price per week with a holiday because one is a holiday. Okay. Then the weeks without a holiday. Without holiday means the zero case. So it means the definition include several things to be noted. First, let me change the color for each one. First, it is talking about that number. It is coming from the slope. Second, it is talking about the quality that we are discussing. The quality is uh, first of all, it is talking about the change. The change should have units. So it is pi is greater in weeks. So it should be price sold per week and y greater because it is a positive sign. And then the characteristic. So it's a holiday. So holiday is where holiday variable equal to 1. And then it talked about without holiday, that name should come from holiday equal to 0. So if it had some other name, it will come here. And what about the last term? So last term comes from the other control variables. Since there is only one control variable, so it says a given this same price. If there are more than one control other variable, then we write as given other variables. So this is a way we interpret our dummy variable. So let's continue and let's see what further we can get out of it. So what will happen if there is more than two levels? So suppose we have a variable that is house price and it depends upon square feet area, and we add a new variable which is style. It is ranch, split level or condo. So so it means there are three types. So we will make two dummy variables. And why two dummy? Because we will make pairs, uh, one for the ranch and split, another for any two out of them. So we can pick the ranch and condo or split and condo. So it depends upon how you want to compare. So both ways are suitable. So both ways are already used in literature or in econometrics. So let's see what it has done. So it had made condo as a default category. It is up to the discretion of a researcher which category should be moved to condo. It is done in Excel using coding. Okay, so he has made a new variable x2 which is 1 for ranch and 0 for not ranch, and 1 for split level and 0 for not split level. Okay, so it means definitely ranch when it is ranch, it means it can be split or condo. And when it is split, it is definitely it is not split. It could be ranch or condo. So it means there is now a little bit confusion. So how to solve it? Let's see how they are doing it. So our variable is y depends upon beta 0 plus beta 1x. That is the area. Beta 2 x2 is the variable for ranch or not, and x3 is for split level or not. So what is beta 2 telling us? Beta 2 shows us the impact of price of if the house is a ranch style as compared to condo. Why? Because we already know that. Let's see in another example, and then I will tell you how I came to know that it is comparing with condo. First of all, I know when I did it, but how from regression. B3 shows the impact of price of a house if the split style is it is a split style as compared to condo. So this is the interpretation of the x2 and x3. So let's move forward and see how it is solving it. So suppose we have estimated equation y is equal to 20.43 its intercept plus 0.045 x1. So house size has a positive effect on house price. X2 is the ranch style. Let me write it here so that we can remember. So it is ranch and it is split. So both have positive effect. So we will put the value first of all 0 in both, then 1 here and then 1 here. We cannot put 1 both side because we already know house cannot be ranch and split both times. So first of all we will put 0 in both. So definitely if ranch is not there and split is not there, it is condo. That's why I came to know that the base is condo, because the construction is done in a way that it cannot be both together. So when x2 is 0, it will be 0. And when x3 is 0, it will be 0. So both are removed. So only x1 is there. So y is 20.43. So this is the answer. And when house is a ranch, it means it is not a split. So x3 is 0. So y is 20.43 plus 0.045 plus 23.53. So it is equal to 1. So this will be added with this term. So what does this number mean? So with the for a house with the same square feet, a split level house will have an estimated average price. How much more? It is wrongly written here. So split level house is, yes. So it is not a ranch. So it is a split level house. So it should be x2 equal to 0 here. So it's a typo here. So let me correct it. So if a house is a ranch, it should be x is equal to 0. That is right. But if it is a this integration should come down and this integration should come up. Okay, so then it will be correct. Okay, so what it is shown as here, that with the same square feet, a ranch will have an estimated average price of $23,530 more than a condo. So what it is telling us, that if you are buying a standard house which is a condo, and if you shift to a ranch house, it will cost $23,000 more, because it has more value maybe. And then if for a same square feet, a split level house will have estimated price $18,400 more. So it is more expensive than the house with a condo. So this way we, since the dummy variable has 3 levels, so we have 3 equations. So this is an equation for condo, this is an equation for ranch, and this is equation for split level. Okay, let's see what does it let us know in the next slide. So we'll go on the next slide a little bit. So what does it give us? So in this way, we have a 3-level regression. Let me draw it here. So we have a y-axis, black color. So let me have a y-axis, and then we have an x-axis. So we already know the price should come here. So it is x1 and this is y. So for the case of condo, intercept is something 20.43 and it is positively sloped. And for a ranch, it is 40 point something, 43 point something. It is a bigger number, so it will be with a different color. Let me take blue, so it will be higher. Similarly, for a split level, it is green. So let me draw with green, which is higher. So it means, what does it tell us? That the house size has a uniform effect on y. If it increases, it has the same slope. But what is the actual value depends upon the type of house. If it's a condo or ranch or split. So this means that our estimates could go wrong if we do not use dummy variables. So, and if the dummy variable is useful, it is dependent upon if this is significant and this is significant or not. So how we do it? We already studied that its t value should be greater than 1.96, or t value should be less than minus 1.96, or its p value should be less than 0.05. So this way we can identify if what you call it, the the dummy variable is significant.